Hello, my name is Principal Singh. I am Professor of Physics. Today we will study a position time graph in the one-dimension kinematics. So here I have shown the x-axis. This is the origin, and the particle is starting somewhere on the x-axis. The position of the particle varies as the graph shows on the board, x versus t graph. The black one is the x versus t graph, and the informations that we can fetch out from the position time graph are the number one, instantaneous velocity. We can also find out the average velocity. We can find out the average speed. In fact, we can also find out the instantaneous speed. We can find out the average acceleration and the instantaneous acceleration also. So how we can find it out? The very important thing is the slope of the position time graph gives the instantaneous velocity. Now what is the slope of position time graph? If we draw a tangent at any point, then the angle that tangent make with the x-axis, with the time axis over here, the tan of that value, tan of that angle gives the slope of the tangent. So look at A. At A, the tangent drawn makes an angle θ1. At B, the tangent makes an angle θ2 with the horizontal axis. At C, the tangent is parallel, and at D, the tangent makes an obtuse angle. So we write down the instantaneous velocity as dx upon dt, the time derivative of the position. So dx upon dt at A is VA, which is equal to the slope of the position time graph, which is tan θ1. And you see that the slope is positive because that angle is acute. So the velocity is positive. The particle is moving in the positive direction, that is along the positive x-axis. At B, the slope has increased because theta has increased. So you can say the velocity at B is more. At C, you see that the velocity has become 0. The instantaneous velocity at C is 0. The particle has come to rest for an instant at the point C. VC, dx upon dt at C is VC, and at point D, the slope, the tangent is making obtuse angle, so the velocity is negative because tan theta will be a negative quantity. So at D point, the particle has negative velocity, which means that the particle is coming back. It is coming in the negative direction. So in this way we can find out the instantaneous velocities. Now come to the average velocity. The average velocity is simply the change in the position, that is the displacement upon time taken. For example, from A to B, we have to find out the average velocity. The time taken, the position at A is XA, the position at B is XB, the time at A is TA, and the instant at B is TB. So the time interval from A to B is TB minus TA, and the displacement is XB minus XA, that is the change in the position. So V average from A to B is equal to XB minus XA, the displacement, divided by time taken, TB minus TA. In the same way, you can find out the average velocity from any starting interval to any ending interval. You can find out the average velocity from TA to TB. You can find out the average velocity from TA to TC also. Now we will find out the average speed. The average speed is the total distance travelled by the particle upon time taken. In this case, the average speed, the magnitude of the average speed is the magnitude, it's a positive quantity, but it is not equal to the magnitude of the average velocity. We can find out the average acceleration also. The average acceleration is defined as the change in velocity upon time taken. So the change in velocity upon time taken, that is, if we want to find out the average acceleration from, let's say, instant ta to TB. So we know that velocity at A is VA and velocity at the B is VB. So the change in velocity when the particle moves from point A to point B is VB minus VA. This is the change in velocity. You can write down by delta V, which represents the change in velocity. If you if you divide it by the time interval, that is time taken from A to B, is TB minus TA. So this gives you the average acceleration of the particle. You can also find out the instantaneous acceleration. We can just have an idea about the instantaneous acceleration, that if you see that the velocity, the slope at A is less, and as we move, as the time increases, the slope is increasing, that is, the particle is accelerating. So you can say that, you can have an idea that the slope of the particle is increasing, so the acceleration is positive here. When the slope is increasing, it simply means that the speed is also increasing here, and the acceleration is positive because the velocity is also positive. If the acceleration is positive and velocity is positive, it means that the body is speeding up, it is gaining the speed. If the acceleration is negative and velocity is positive, it means that the particle is moving along positive x-axis, but its speed is decreasing. In the same way, if A is positive and V is negative, it means that the particle has negative velocity, that is, the particle is moving in the negative side and its speed is decreasing. In the same way, if A is negative and V is negative, that is, the acceleration is negative, velocity is negative, it simply means that the particle is moving in the negative direction and its speed is increasing. It is speeding up in the negative direction. Thank you.